After a man-made or natural disaster, an air base could be faced with extensive damage. The damage could be caused from a conventional wartime attack by enemy ground and air forces. In today's environment, damage could be the result of an act of terrorism or natural disaster, such as hurricanes, tornadoes, floods, or wildfires. Depending on the type of disaster, numerous fires and injured personnel may require emergency rescue and medical care. The recovery of essential facilities and utilities may be required to ensure mission accomplishment, such as the launch and recovery of aircraft. No matter what the cause or type of damage, it is the base civil engineer's responsibility to recover the base. If mutual aid agreements are activated, civil engineer personnel may also be asked to assist the local community with their recovery efforts. Until help arrives, recovery activities will depend on the resources available on the base at the time of the incident. Attrition can be expected to steadily decrease the availability of manpower, material, equipment, and vehicles needed for base recovery.
The ability to respond to any contingency situation and to protect the vital assets needed to recover the base requires pre-planning. This is done by developing the Base Civil Engineer Contingency Response Plan. When developing the BCE Contingency Response Plan, AFI 10-211 Contingency Response Planning and AFPAM 10-219 Volume 1 Contingency and Disaster Planning should be used.
During contingency planning, resource protection is an essential element. Without adequate resources, even the best plan is doomed to failure. Resource protection consists of measures such as camouflage, concealment, and deception, hardening, redundancy, chemical warfare defense, and dispersal. In warfare, it is likely that no single method of resource protection will be completely effective by itself. Instead, several techniques may have to be used to complement each other to provide a greater degree of protection. This presentation deals primarily with resource dispersal, even though camouflage, concealment, deception, and hardening requirements are intermingled. To fulfill the planning requirements of AFI 10-211, resource dispersal should be included as part of the Base Civil Engineer Contingency Response Plan under Annex B, Natural Disasters, and Annex C, Enemy Attack. The purpose of dispersing recovery resources is to reduce their vulnerability from enemy action, natural disasters, or terrorists' activities by relocating, spreading, and separating them from a central, possibly dangerous location into a number of less dangerous areas.
When you are planning for the possible dispersal under each contingency operation, you should identify the resources to be dispersed, select the dispersal sites, develop dispersal methods, and establish dispersal criteria. When you are considering which resources should be dispersed, your primary consideration should usually be the importance of the resource to the recovery effort. For example, if you're planning a dispersal in anticipation of a violent storm, the most essential equipment items may be front-end loaders and dump trucks for clearing debris after the storm. For dispersal prior to an attack, the most essential resources may be those personnel, equipment, and materials needed to perform bomb damage repair, fire suppression and crash rescue operations, as well as emergency utilities and facilities repair.
The ideal dispersal site is one that protects the resources from any conceivable threat or disaster. The site should be readily accessible and have provisions for communications with the Damage Control Center and the Fire Operations Center. At a minimum, dispersal sites which are to be used during hostile attacks should be located away from high-threat areas of the base. There should be multiple sites to increase resource survivability. These sites should also provide good natural cover and concealment with protection from attacking forces. Identical equipment items such as excavators, graders, dump trucks, and front-end loaders should be dispersed to separate sites to ensure at least one of each type survives. During natural disasters such as a hurricane, when the flying units have deployed, aircraft hangars and shelters should be used as dispersal sites for civil engineer recovery equipment. However, in wartime, shelters may be a target. Some bases have abandoned or unused munitions storage facilities, which are ideal dispersal points for resources. These structures are usually hardened and provide substantial protection from the destructive effects of a major disaster, such as a tornado. However, they too may become targets during wartime. When an attack is imminent, various terrain features of the base or surrounding countryside may offer other suitable dispersal locations. Under combat conditions, concealment of vital assets should be a decisive factor for dispersal site selection. The same considerations used in dispersing vehicles and equipment should be used for personnel. However, whenever possible, personnel should be dispersed in hardened, filtered air, overpressured shelters. In case of a no-notice attack, trenches, berms, basements, behind buildings, and bunkers could be used for splinter protection and expedient shelters for dispersed forces. When hostilities are expected in overseas areas, military dependents will be evacuated stateside, time permitting. Vacant housing units can be used as dispersal areas for personnel, as well as bed-down facilities for incoming forces. Depending on location, civilian warehouses or other storage facilities near the base could be rented as temporary dispersal locations during an emergency. Railheads and port facilities near the base make good dispersal facilities, but they may also be targets in their own right. Large base structures, such as gymnasiums and recreation centers, could also be used in emergencies as temporary dispersal points and personnel shelters. These types of facilities should be evaluated carefully to ensure they would provide adequate protection from the anticipated threat.
Once dispersal resources have been identified and dispersal sites selected, several other areas must be considered. These are the distance to the dispersal site, the threat condition, and the time available for dispersal action. Most civil engineer heavy equipment and vehicles are motorized and can be driven to their dispersal sites. However, tools and related support equipment must be towed or transported in vehicles, small trailers, and tractor trailers. Hard-to-move material like AM2 and fiberglass matting, sand, gravel, and rock fill material should be pre-positioned in stockpiles at key locations around the base. If possible, a vehicle maintenance mechanic, spare parts, and refueling capability at the dispersal locations will help to ensure that recovery vehicles and equipment will continue to operate if the main fuel and maintenance facilities are damaged or destroyed. If personnel will be located at dispersal sites for extended periods of time, as a minimum, sleeping bags, water, and rations will be required. One of the most crucial factors in conducting an effective dispersal operation is time. The greater the warning prior to an emergency, the more attractive dispersal becomes as a resource protection option.
The base civil engineer's decision as to when assets should be dispersed depends upon the perceived impact of the threat and estimates regarding the time available for dispersal. For natural disasters, the base civil engineer should have some background data as to the type of destruction that may be expected and can base decisions on estimates of how these conditions could impact the recovery operations.
During wartime conditions, the base civil engineer should be able to find basic guidance on when to disperse included in AFI 32-4001. This publication gives basic guidance for the development of Air Force programs and procedures for the protection of people and resources from the effects of war. Local survival and recovery plans should outline civil engineer actions under the threat of nuclear incident and terrorist actions. Regardless of the type of threat anticipated, the ultimate responsibility for the safety of recovery resources rests with the base civil engineer. Any dispersal actions necessary to protect these assets should be taken as early as possible.
If, after careful consideration, the civil engineer command element decides that dispersal is a valid option, the following actions should be taken. Marshal all recovery forces to be dispersed and provide them with a comprehensive briefing of the actions to be taken. Changes to the pre-planned dispersal activities should be emphasized. Of special importance are changes to dispersal location, dispersal assets or methods, reporting and recall procedures. Organize dispersal assets and arrange for the necessary transportation. This step includes all activities necessary for mobilization of dispersal assets, like loading equipment and materials in and on trailers and trucks.
Vehicle and equipment operators must perform operational service checks on equipment that will be driven to the dispersal location. Organize convoys for land movements to dispersal sites both on and off base. In some instances, you may have to arrange airlift support for long-range dispersal or change dispersal routes as needed to reflect the current situation. Assembled assets should be moved to their dispersal locations as quickly and safely as possible. During wartime, it is especially important to ensure that valuable resources are not exposed or concentrated in a single location when an attack starts.
Dispersed forces must be able to maintain contact with the Damage Control Center or a relay point. The Damage Control Center must be advised of any factors that affect the capability of the dispersed forces to accomplish their post-disaster or post-attack mission. Communications may consist of a variety of means and should employ more than one method for backup purposes. Some alternate techniques, such as signal flags, mirrors, and lights, may be used. While useful, these devices have limited capabilities. If signals are used, their meaning must be prearranged and simple. If radio and telephone communications fail, runners are probably the best way to communicate because they can carry written as well as verbal communications and grid maps with damage, UXO, and other information vital to base recovery operations. If there is a drawback to using runners, it is the time it takes a runner to get from one location to another and return. Runners can also be killed, captured, or injured.
It is vital that dispersed resources be secured and protected from the effects of a natural disaster or enemy action. Otherwise, the purpose of the original dispersal will be defeated, and the dispersed forces will not be effective in responding when recalled. Camouflage, concealment, and deception should be incorporated into wartime dispersal protective facility design and siting, as well as into vehicle and equipment dispersal locations. Pre-planning for dispersal locations should include using wooded areas or elevation changes that blend facility and vehicle contours into the surrounding terrain, or facilities where earth and grass coverings are used for hardening when possible. In areas without natural cover, liberal amounts of camouflage netting may also be used on facilities and vehicles. Placing salvaged and out-of-service vehicles in open areas away from operational locations as decoys is highly recommended.
After a natural disaster or an enemy attack, as the damage assessment teams are recalled to conduct damage reconnaissance, recovery personnel should accomplish a thorough inspection for possible damage to recovery equipment, materials, and immediate haul routes. The status of each dispersed team should then be reported to the Damage Control Center. After an enemy attack, when the Damage Control Center gives the dispersed recovery teams clearance to move, they should move to their respective repair locations in small mixed groups of unlike equipment at appropriate intervals to prevent explosions, accidents, or contamination from crippling the entire team effort through the loss of critical recovery assets. During this movement, all personnel should be constantly vigilant for unexploded ordnance and facility and utility damage, and report these findings to the Damage Control Center. If a re-attack occurs while repairs are in progress, recovery personnel should disperse and protect their equipment as much as possible before taking cover. If splinter protection is not available, vehicles should be dispersed randomly away from the threat area. If possible, there should be approximately 300 feet between vehicles. Earth berming, camouflage netting, and decoys are protective measures that should be considered prior to actual recovery operations. These measures can be used to provide minimal protection for recovery personnel and equipment during surprise attacks. As recovery actions are complete, team members and equipment that are not needed to assist other teams repairing critical utilities and facilities can be returned to the dispersal area. After all critical repairs are made, equipment should be reserviced with fuel, hydraulic fluids, coolants, and any required maintenance, and then returned to dispersal sites. Recovery crews should return to their shelters for food and rest in preparation for the next attack.
Recovery activities after a natural disaster will depend largely on the type of disaster that has occurred. For example, after a hurricane, you can expect to have a lot of structural damage to facilities, downed power lines, trees and other debris blocking roads caused by high winds. Storm surge can cause a large amount of structural damage to facilities, bridges, and roads along the coast. Flooding from heavy rain can cause a lot of damage, as well as contaminate sources of drinking water. The spread of disease from flooded wastewater treatment facilities is also a strong possibility. After a tornado, you can also expect a lot of wind and water damage. Add to this list lightning strikes and the possibility of damage from hail. Recovery from ice and snowstorms would probably center around clearing airfield pavements, main roadways, and the repair of downed power lines. If the snowfall was heavy for long periods of time, roofs could collapse from the weight of the snow. A major flood is one area that will most likely involve both military and civilian cooperation through memorandum agreements. Wildfires are another area where mutual aid agreements between military and civilian authorities will come in handy. Considerations for dispersal in conjunction with a natural disaster are much the same as they are for an attack. Time is always a consideration. A tornado or earthquake may not give you time to disperse assets, while the notification of an impending hurricane should give ample time to disperse recovery assets. Protection is another consideration. Recovery assets must be protected from flying debris caused by high winds in much the same way as they are from battle damage. In areas where flooding could be a problem, dispersal locations on high ground should be considered. Access to and from dispersal locations is also important. Facility debris, downed trees, or power lines can be cleared from roads fairly quickly. However, a damaged bridge or flooded roads can effectively isolate badly needed recovery teams and assets from where they are most needed.
As you have seen, the task of recovering the base after a natural or man-made disaster will depend on the resources available to you at the time of the incident. Therefore, pre-planning to meet any contingency situation is vital. Your base civil engineer contingency response plan must include resource protection from both natural and man-made disasters. Resource protection includes resource dispersal, as well as adequate shelters and splinter protection for personnel and equipment. This presentation has been produced as an introduction to resource dispersal. Additional in-depth information can be found in these Air Force publications. Remember, contingency response planning and resource protection are an essential to base recovery and mission accomplishment. Let's do our part to keep them flying.